Hi students, நம்ம இந்த வீடியோ என்ன பார்க்க போகிறோம்னா combination of heat engine and refrigerator problem பார்க்க போகிறோம். Okay, so a reversible heat engine operates between 600 and 40 degrees centigrade. The engine drives a reversible refrigerator operating between 40 degree and 10 degree. So the net work output is 370 kilojoules. Heat received by the engine is 2100 kilojoules. So determine the cooling effect. First you should draw the diagram. So this is heat engine. Okay, this is a heat engine. It operates between 600 degrees centigrade and 40 degrees centigrade. Okay, so 873 Kelvin and 313 Kelvin. Okay, so a reversible heat engine operates between 600 degrees centigrade and 40 degrees centigrade. The engine drives a reversible refrigerator. So okay, this engine drives a reversible refrigerator. Okay, that refrigerator operates between the two temperature. One is 40 degrees centigrade and the zinc temperature is minus 10 degrees centigrade. Okay, in Kelvin scale 313 Kelvin and 263 Kelvin. Okay, so and the another data is the net work output. So the net work output is 370 kilojoules. Okay, and another data is heat received by the engine is, so here the heat supplied is 2100 kilojoules. Okay, so determine the cooling effect. Okay, so this is the QS, here QR, here heat rejection, here QS. Okay, so you can find out the QR value, that is the cooling effect. Okay, now we proceed further. இப்போ நம்ம என்ன பார்க்க போகிறோம்னா COP of refrigerator பார்க்க போகிறோம். COP of refrigerator. So COP of refrigerator is QR divided work done. Okay, heat engine work done is called as W1. Okay, so the input heat, the work output from the heat engine is W1. Okay, W2 ங்கிறது refrigerator நம்ம input கொடுக்கக்கூடிய, so here W2. Okay, so now QR divided W2. Okay, so heat rejection is nothing but here the temperature, lowest temperature, here highest temperature minus lowest temperature. Okay, you should write in terms of temperature. Okay, so the lowest temperature is 263 Kelvin divided, here the highest temperature is 313 minus 263. Okay, now we get QR divided W2 is equal to, the value is 5.26. Okay, now we move on calculation of efficiency of the heat engine. Okay, here the efficiency is nothing but work done divided heat supply. Okay, so for heat engine it is W1, heat supplied is Q1. Okay, so W1 you don't know, Q1 is 2500. Okay, now the W1 is calculated by highest temperature minus lowest temperature efficiency of the heat engine. இப்போ heat engine efficiency calculate பண்ணும்போது W1 divided by Q1 வரும். Okay, so you already know இது எப்படி எழுதலாம், 1 minus TL divided by TH எழுதலாம். Okay, 1 minus TL ங்கிறது lowest temperature. For heat engine lowest temperature is 313. Highest temperature is 873. So now W1 divided by Q1 is 2100. Q1 is 2100. 873 divided 313 divided 873. So now the W1 is 1347.1 kilojoule. So first என்ன பண்ணோம், COP of refrigerator calculate பண்ணோம். Okay, and the second one is efficiency of the heat engine. So now third one is the net output is W1 plus W2. Here the W1 is heat engine, it is work producing device. So here W2 is refrigerator, it is work absorbing device. So here the W2 is minus, so minus W2 is equal to W net minus W1. So W2 is equal to W1 minus W net. So the W1 value is 1347.1 minus W net value is 370 kilojoules. Okay, now the W2 value is 977.1 kilojoules. Okay, now you can easily find out the cooling effect. So you see the first step, the step is QR divided by W2. QR divided by W2 is equal to 5.26. Okay, so QR is equal to W2 multiplied 5.26. Here the W2 is 977.1 multiple 5.26. The answer of QR is 5139 kilojoules. This is the cooling effect from using refrigerator. Thank you for watching.